Right. Next, we will take a general example, which is sine wt by pi t. So what will be the corresponding Fourier transform? This fellow will have what as Fourier transform? This fellow will have a rectangular function from minus w to plus w as the Fourier transform. So what is the highest positive frequency? It is w, and hence what is the bandwidth of this signal here? W radians per second, or W by 2 pi hertz. Now if you take sine Wt by pi t whole power n, so if you want to find bandwidth of this signal, so definitely what will happen in frequency domain? So we have to convolve this rectangle with itself how many times? N times, and hence what will happen? The bandwidth of the function will increase, and that will be equal to Nw radians per second, or Nw by 2 pi hertz. Okay, right. So next example, let us take sine Wt by pi t convolved with sine Wt by pi t. We want bandwidth of this whole signal. But if you look at the corresponding Fourier transform, so what do you see? If you look at the corresponding Fourier transform, so what do you see? You get a rectangle from minus w to plus w, and this fellow is multiplied with another rectangle again from minus w to plus w. So what will happen? Amplitudes will be 1. So if you multiply these two functions, what do you get? Again you get the same function, and hence what happens to the bandwidth? Bandwidth would be again W radians per second, or W by 2 pi hertz. So we can extend this result to n convolution. So what do I mean by that? If you convolve sine Wt by pi t with itself multiple number of times, bandwidth is not going to change. Why? You have to multiply a rectangle, and rectangle. So all are same rectangles, and hence what will happen? You will get again the same rectangle. So that rectangle will be from where to where? From minus W to plus W, and hence what happens to the bandwidth? Bandwidth would be W radians per second, and that should be equal to W by 2 pi hertz. Okay, now let us make our life little bit complicated. What do I mean by that is, let us take this example. Okay, so let us take x of t to be equal to sine 4000 pi t by pi t whole cube plus sine 2000 pi t by pi t whole power 4. So definitely we know that the Fourier transform of this function exists from where to where? Whole cube is there, so definitely the the first function can be written as what? Sine 4000 pi t by pi t multiplied with itself 3 times, and hence what happens to the bandwidth here? So what happens to the bandwidth? So this is multiplication in time domain, and hence what happens to the Fourier transform? We have to convolve. So overall convolution will give you some shape. We are not worried about the shape, but that shape exists from where to where? Minus 12,000 pi to plus 12,000 pi. Okay, similarly what happens to this fellow? So sine 2000 pi t by pi t whole power 4 is there. So sine 2000 pi t by pi t whole power 4 means you have to convolve in Fourier domain a rectangular function with itself 4 times, and hence you get this shape. We don't know the shape, but the overall function exists from where to where? Minus 8000 pi to plus 8000 pi. So if you add these two fellows, overall function exists from where to where? Minus 12,000 pi to plus 12,000 pi. Correct? This is from minus 12,000 pi to plus 12,000 pi. This is from minus 8,000 pi to plus 8,000 pi. If you add them, you will get a function from minus 12,000 pi to plus 12,000 pi. So what will happen to the bandwidth then? Because of addition, so this highest positive frequency is 12,000 pi. So you will get bandwidth to be 12,000 pi radians per second, or 6,000 hertz. Okay, now let us look at this function little bit. I mean, what do I mean by that is, we will remove this sign. Okay, so if you remove this sign, what will happen? So in time domain, these two signals are getting multiplied. So sine 4000 pi t by pi t whole cube multiplied with sine 2000 pi t by pi t whole power 4. So because these signals are getting multiplied, what happens in frequency domain? The corresponding Fourier transforms should get convolved. So if you convolve these two functions, so what will happen here? 1 by 2 pi is there. Okay, so this whole thing is multiplied with 1 by 2 pi. Okay, because we are multiplying in time domain. In frequency domain, 1 by 2 pi will come. 1 by 2 pi is multiplied with convolution of this fellow's Fourier transform and this fellow's Fourier transform. So what should be the final answer here? Because these two fellows are getting convolved, so the overall Fourier transform exists from where to where? Shape we don't care. So overall Fourier transform exists from minus 20,000 pi to plus 20,000 pi. Why minus 12,000 minus 8,000 is minus 20,000. 12,000 pi plus 8,000 pi is 20,000. So what is the highest positive frequency? Highest positive frequency is 20,000 pi radians per second, and hence what happens to the bandwidth now? Bandwidth would be 10,000 hertz or 10,000 or 10 kilohertz. Okay, yes, as a last note, instead of multiplication I put convolution here. So once I put a convolution, what will happen here? So because you are convolving in time domain, so what should happen in frequency domain? Frequency domain, the corresponding signal should get multiplied, correct? So these two functions in frequency domain, they should get multiplied. So if you multiply these two functions, what will happen? And this 1 by 2 pi will not be there because for this case. Okay, so because of convolution in time domain, there won't be 1 by 2 pi in frequency domain. Okay, if you multiply these two, the overall product exists from where to where? Minus 8,000 pi to plus 8,000 pi. Why? This fellow exists from minus 12,000 pi to plus 12,000 pi. This fellow will exist from minus 8,000 pi to plus 8,000 pi. So product will exist from minus 8,000 pi to plus 8,000 pi. So what will happen to the bandwidth then? Bandwidth would be again 8,000 pi radians per second, or in terms of hertz, that should be 4,000 hertz. Okay, right. Next, so all these things we will, whatever we have seen three cases in the previous problem. So let us generalize that result. Okay, so as the 16th problem, don't look at the 17th one, let us look at 16th one carefully. Okay, so we want to find the Fourier transform of, not Fourier transform, the bandwidth of this whole signal, which is sine w1t by pi t whole power n convolved with sine w2t by pi t whole power m. Okay, so what is the bandwidth of the first signal? That is nw1 by 2 pi, because we want to measure in hertz. And similarly, what is the bandwidth of second signal here? That should be mw2 by 2 pi. And hence what happens to the bandwidth of this signal? So bandwidth, because this fellow Fourier transform will exist from where to where? This fellow will exist from minus nw1 to plus nw1, and this fellow will have Fourier transform from where to where? Minus mw2 to plus mw2. So what will be the, because we are convolving in time domain, so what should happen in frequency domain? These two fellows should get multiplied. So after multiplication, whoever is minimum, that fellow would be the highest positive frequency, and hence bandwidth of the signal would be how much? Minimum of nw1 by 2 pi and mw2 by 2 pi. Okay, right. So now I replace this convolution operation with just multiplication. So what will happen here? Because we are multiplying in time domain, so what should happen in frequency domain? These two functions should get convolved. So because of convolution, what will happen? The overall Fourier transform will exist from where to where? Minus nw1 minus mw2 to nw1 plus nw2. So what is the highest positive frequency? Highest positive frequency would be nw1 plus mw2. Okay, so you get plus. Okay, so that would be the overall bandwidth, nw1 plus mw2 whole divided by 2 pi hertz. That would be the bandwidth of the signal. So as a last case, if I add plus here, Okay, as the last case, if I add plus, what will happen here? Because the signals are getting added, Fourier transforms also should get added. So if you add these two functions, what will happen? You should overall highest positive frequency would be what? It is whichever is larger, MW1 or NW1 or MW2, and hence what will happen to the bandwidth? That should be maximum of these two guys, NW1 by 2 pi and MW2 by 2 pi. Okay, so in that way all the three cases we have covered. Okay, right.